Hello everyone, so in this video we want to determine the direction of polarity of the indicated bonds in the following compounds using our symbols of delta plus and delta minus. Alright, so the ability of an atom to attract the shared pair of electrons towards itself is what we call electronegativity. Polarity in covalent bonds arises as a result of differences in electronegativities of the bonded atoms. The difference in electronegativities result in the separation of charge, creating what we call a dipole moment. The more electronegative atom can attract the shared pair of electrons more strongly, generating a partial negative charge on itself, while the less electronegative atom develops a partial positive charge, of course, by default. So let's go ahead and list out our electronegativity values. So these values can be either given to you by a professor, found online, or even found in your textbook. Starting off with our oxygen atom, this presents an electronegativity value of 3.5. Carbon has a value of 2.5. Fluorine has a value of 4.0. All right. So using this information, we can go ahead and take a look at these two different examples. So in our first molecule here, oxygen, which has a electronegativity value of 3.5, is more electronegative than our carbon, which has a electronegativity value of 2.5. So actually what we should do is actually draw out our structures first. So for our molecule A here, we do all this in purple. So we have our terminal HC3 or H3C group. Then we have the central carbon, H2, and then we have our alcohol group, OH. Like we said, oxygen has a value of 3.5. This means it's more electronegative than our carbon. So carbon does develop a partial positive charge, and oxygen develops a partial negative charge. So we represent a partial negative and partial positive with our delta, our lowercase Greek symbol delta, and a plus here. So this is partially positive, and our oxygen here is partially negative. Now, drawing out the second structure, structure B, we do all of this in our blue color. Again, we have our terminal H3C group, central CH2. And towards the end, instead of our alcohol group, we will just have a fluorine. So in our second molecule, fluorine has a electronegativity value of 4.0, and it's more electronegative than carbon, which has a value of 2.5. So the carbon develops a partial positive charge, and a fluorine develops a partial negative charge. So these two here in highlights going to be my final answer for this problem. Again, we have shown the directional polarity of the indicated bonds in our following compounds by using our delta plus and delta negative signs, all because of our electronegativity values.